Hello everyone. So this is our 18th tutorial in the series of SolidWorks tutorials. In this tutorial we discuss about drawing module. In previous lecture we also discussed about the drawing module, in which we clear about how to import the various 3D models to the drawing or drafting module, and how to draw the various views such as top, right, bottom, and so on. We also discuss about the first angle and third angle projection. In this video we discuss about how to get the section view in the drawing module, and how to give certain dimensions, how to use various other annotation symbols and all of the stuff. So let's start. So just go to file, or you just click here new and select this drawing module of this software, and then click OK. So as you can see, when you click the drawing module, you are asked to about the type of sheet template you required. So we select the A4 landscape ANSI, then I click OK here, or you can select A4 NSI ISO standards also. So it depends upon you which sheet you require. Okay, so I need a landscape A4. You can choose A3 also, you can choose A2 also, so no issues. So I select, let us say I select A3, and then click OK here. The sheet format will be A3 right now, and it is ANSI landscape format. Okay, so this is your sheet format. So this is the title block, in which you can give your all the identities like name, the angle of projection symbols, scale factors, dimensions, company name, and all other stuff. All the relevant information is to be given in the title block. So before starting, we have to select the sheet here and right click to get the properties. So when I click properties, you show the properties of the sheets are shown to you. Okay, so in this you can see the scale factor of the sheet is 1:1. Okay, and the angle of projection must be first or third. It depends upon your requirement, whether you want to work in first angle or whether you want to work in third angle projection. So let us try that we have to work in third angle projection. So I just select third. Okay, and then I just select apply changes here. Okay, so this sheet is now third angle projection A3 format of ANSI landscape. Okay, so now we have to select the views, or we have to call the 3D model in this sheet. So we have to go to the now view layout. In view layout we have 3 different standard views, and one was for model view. So in standard 3 views we have only 3 views, such as front, top, and side view. But in case of model view, you can select the view as per your requirements. It is user defined. So I just click model view here, and then I go to browse. When I click on browse in the property manager, I have to select my drawing where I placed it. So I select my drawing and I just drag my mouse on the sheet. So you can see my mouse is your sheet contains a square box which consists of your drawing. Okay, now when I click here, as you can see, your drawing is created. This is the front view of your pipe bend. This is the product I want to draft. Okay, so this is the bottom view, and now here we have our top view, and this is your right side view. Fine. So this is how you can define the top view also. And if you want to define the your isometric view, so you can define here also. You can place anywhere right now and click OK, and then just drag this isometric view to some other position so that you can define it later. Fine. So this is your front view. This is the first or the major view. Now if any changes occurred in this view, this is the first your major view. Okay, so any changes occurred in this view will reflect all the changes in your all other views, like right side view, top view, bottom view. So I just select this and delete this top and bottom view. Okay, first Now this is the combination. So this is how you can define things. Okay, so just drag the objects so that they are equally distant from each other. So this is your front view, this one is your we can say top view, and this is your right side view, and this one is your isometric view. Fine. So this drawing is in third angle projection, and now I have to define whether the drawing of other parameters, like whether you want to show the hidden lines, and click OK here, select the hidden line option. You can see all the hidden lines appears on all the different views. Now in isometric view I don't want any hidden lines or any other object, so I just select the shaded portion with edges. So this defines your isometric view in a 3D platform. Okay, so this is how you can define your isometric view in 3D platform with shaded region and with edges. Okay, so this is how you can define all the views. Now what I want to define the section view of this pipe. Fine. So for that I have to select the section view in the view layout. You can see a section view option here. Then I select whether you want to cut the pipe in half in vertical direction or in horizontal direction or at auxiliary view or in aligned direction. So I just select that I want to cut this pipe bend in horizontal direction. So I just select this from this point to this point and then click OK. See, my view is created right now. See, so this is the section view. This is how you can create the section view, and this is the section plane AA, and it is written here that it is section AA. Now press escape to enter the command. So what I do, I just select this sectional plane, vertical section plane, and cut the bend into half, and you can see the section view of this pipe is seen to you. Okay, now what I need here, that these defines that this thing is hollow from inside, and when there are some section lines are there, this means there are certain material, that means it is a solid structure here, and when there is no section lines, this means it consists a hollow structure inside it. Okay, now you can define the section view also. Just double click on these section lines and unselect this material cross hatch and give the scale factor as 4, or you can define 3 also to as per your requirement. You can see the gap between these two lines, section lines, or the pitch of these section lines becomes narrower, and they are become more close to each other. Now when I click OK here, you can see the section view is properly created. Now you want to give that your section view consists of a central line parameter. So go to annotations. When you click annotations, you can define this center line. Like from this option, you just select the center line option here and click the outer edges of the pipe. See, the section, the center line is created. So this is how you can define the center line. Click OK. Now if you want to define certain center mark of the circle, so by default there are these are the circle having a center marks. All circles have having center marks, so no need to define it. Hatching, I told you when you click here, you can define the hatching, or you just double click the hatching in this section view and you can change it as per your requirements. So this is how you can create the section view in the drafting. So section view is just to create whether provide you the detail of the part or detail of the component you want to draw. Okay, it will define you whether the component is hollow, from where it is cut, whether it is solid or having a different material inside. So it is used to define the details of the components. Press escape to enter the command. Now you want to define your dimensions to it. Okay, so let me select the smart dimension option here. So first of all, I have to define this centerline parameter options. So centerline parameter options, for that I just select this bit like this. Okay, now go to smart dimensions, select the center line, defines the radius as 90, and from this line or you can say from this edge to this center line, it is 175. Okay, press escape, move this section A to bit below of this drawing. See, now again go to smart dimensions. Now click this edge and this center line and define as 170. Fine. And now outer edge as 25. Also this becomes 25. Fine. And now we have to define the diameters. So diameters can be defined here in this circle also, or you can define the diameters in this circle also, no issues. So just select this circle. So this is the outer circle, that is of flange having a 225mm dia, and this is the your inner circle having diameter of 165. This is your circle or the outer edge of the pipe which having a diameter of 97, and this is the smaller circle here having a diameter of 20.50. Now the PCD of these circles, smaller circles, is to be determined. So what I do, I just go to sketch, select a circle here, draw the circle up to this point, make sure this circle is for construction, click OK. Now go to smart dimensions, click this circle and define this diameter as 185. So this is the pitch circle diameter of all the circles. So let us define like this first. Okay, now just drag it. See, press escape to end the command. Okay, so this is how you can define the PCD by going into the sketch tab and select the circle and draw the circle for the PCD. Okay, so all the diameters are shown in this diagram. You can show it in the left side view also, or in the top view also, no issues. And because I choose this because this circle is visible to you and it is all dark and you can define it easily here, and you can see the diameters are also visible to you. This is section plane A, which is by which the cutting will take place, and this section is produces, which is called section A. Now you can see here there is a taper or a chamfer here exist. Now in this case it is very difficult to define the chamfer here in this view. So what I do, I just go to annotations and view layout and then go to select the detail view option. So what I do, I just select this option here and I define this circle. So this is your detailed view of this portion which is inside this circle, and I just drag it and place somewhere else. Okay, see, so this is the your section detailed view of this B part. So this is how you can define the, press escape, or you can change the scale parameter also here. So you just select the user define here and give 1:1. Click OK. So this is your detailed section of this area. So here you can define the chamfer first. So just go to annotations, click on note and just define this as 2 × 45. So chamfer exists of 2 × 45. See, press escape to end the command. So this is how you can define the detailed view, or you can define the view which you want to create. Okay, so detailed views are usually used when you have a complex drawings and you can't able to define the dimensions in the dissection or any other view. So you just have to zoom it out and detail in a detail. So that's why we use detailed section view. So that is how you can go select the detail view, go to view layout and then select the detail view option here. Okay, for section view you have to select the section view. For calling out all the different views for a existing model, you have to collect model view. Okay, and then projected view are used to create the projection of the front view. So this is your major front view. This is the front view, this is your right side view, this is your top view, and this is your section view of this front view. Okay, and this is the detailed view of part B, which is encircled here, and this is your isometric view. So this is how you can define the section view in the drafting model. So drafting is very important. In this, you define all the other parameters like dimensions, characteristics, surface finishing, and all other things, so that the manufacturer can understand that whether what he want to define or what he has to manufacture as per the drawing requirements, okay, or as per the design requirements. So drafting is very important. So you have to define the things very precisely in this. Okay, so all the diameters are visible to you now, all the distances are visible, all the radiuses, all the diameters, all these you can say widths, lengths, okay, from the centers or from the regions are visible to you. So all the detailed section views are also visible. Fine. So this is how you can define the detailed section view in the drafting part or on the drawing module. So I think it's understandable right now. It is clear that how to draw the drafting or how to do the drafting in the SolidWorks. So there are two videos. First one is in SolidWorks tutorial having a series number of 17, in which we discuss how to call the different views, how to define the scale factor, how to define the user defined parameters. Okay, and in this second part of this drawing module, we discuss about how to define the section view, detailed view, how to give dimensions, how to define nodes, how to give datums, center line, center mark, area hatch. Okay, so all these parameters are known to you. Now I think it's clear that how to define the things, how to make drawings. So always make sure that your drawings are in first or third angle as per the requirements of the customer or as per the requirements of your design and drawings. Okay, so you have to select one of these between these two, whether it's first angle or third angle, and make sure that if you select the first angle, your top view will be drawn below the front view, and if you select the third angle, your top view is drawn above the front view. So whatever changes you've done in the front view, so this is the front view, this is your major view, so we call it as a parent view, and all other views are secondary views. Okay, so if you do any changes in the parent view, all the views have those changes. So when it is when there is a change in the hidden options, hidden line options, then all the views have hidden line options. Okay, so this is how you can define things in the drafting view. So I think it's clear all the things about the drafting in the SolidWorks. So I hope you understand all the basics of this, how to draw, how to define the dimensions, how to define the section view also. So thanks for watching and thanks for your support.